Hey everybody, I'm glad you could make it. Let's get going. My name is David Wheeler, and I'm one of the organizers of the Postgres Extensions Ecosystem Mini Summits, a series of free and online mini summits that leading up to the session of pgconf.dev in May, which will be in Montreal on May 13th. The other organizers are Flor Dreys from EDB, Yuri Rashkowski from Omnigres, and Keith Fisk from Crunchy Data. So today is the third of the streams that we have. I'd like to introduce you to Christoph Berg, who's from Debian and Cybertech, and is the world famous Postgres Global Development Group APT Packaging expert and maintainer. He's going to talk to us about extension packaging in APT. But first, I want to tell you that the stream and the closed captions that we'll make in recording after the event and the transcripts that I will be publishing and uploading them to YouTube is supported by the pgconf.dev and their gold level sponsors, Google, AWS, Huawei, Microsoft, and Enterprise DB. So next in the series, on the 23rd of May, in 2 weeks, April, we will have a session on the user point of view. I think it's a panel session that Flor's been working on putting it on together. And the last session before pgconf.dev will be on May 7th, and Gabriele Bertolini is going to talk about extension management in cloud native PG, which is seeing quite a bit of evolution lately, as you'll know from last week's talk. So, I'm looking at two screens and it's just not working. Anyway, so that's where that's at. So without further ado, Christoph, I'd like to turn it over to you.
Okay, so let's. I think you have to stop sharing first.
Oh, sorry. Go ahead. Again, two screens.
No, it should be working.
Thank you.
So, hello, welcome. Hello, everyone. So, yeah, what is this about? It's about packaging things in the Postgres software universe for Debian and related distributions. So we have packages obviously for the Postgres server packages, extension packages. This is what we are talking about today. Application packages and other things. The general workflow is that we are uploading packages to Debian Unstable first. So this is sort of the master copy. And from there, things eventually get to Debian testing. And then once Debian releases, it lands up in Debian stable. Perhaps more importantly for the view today is that the same package is then also rebuilt for app PostgreSQL.org for greater coverage of Postgres major versions. And eventually the package will also end up in an Ubuntu release because Ubuntu is copying Debian Unstable or Debian testing every six months and then doing their release from there. But I don't have any stakes in that. They're just copying stuff. So for an overview of what we are doing in this Postgres team, I can just briefly show you this overview page there. Let me pull in that tab here. Can you see that browser now?
Yes.
Okay, so that's basically the view of packages that I can also scroll in a bit. View of packages that we're maintaining there. Currently, it's 138, mostly Postgres extensions, a few other applications, and yeah, whatever comes up in the Postgres ecosystem there. So to get a bit more technical, let's look at how the Debian packages look kind of from the inside. We have two sorts of packages. We have source packages, which are the source of things that are built from there. The way it works there is that we have a directory inside that source tree called Debian, which has the configuration bits about how the packages created should look like. And from this, the actual binary packages, the .deb files, are built. Over the past years, I've got a few questions about how do I get my application, my extension, and so on packaged. And I wrote that down as a document, so hopefully to answer most of the questions. And I kind of think that since I wrote this down last year, the questions somehow stopped. So if you use that document and liked it, please tell me, because no one has ever given me any feedback about that. So the talk today is kind of loosely based on this thing there. But yeah, let's see. So the I'm not going to assume that you know a whole lot of Debian packaging, but I can't cover all the details here. So I'll keep the generic bits a bit superficial and dive a bit more into the Postgres specific parts. So generally, the most important file in the Debian package is this Debian control file, which describes the source and the binary packages. This is where build dependencies are declared. This is where the package description goes, and so on. So in the Postgres context, we have the first problem that we don't want to encode any specific PG major versions inside that control file. So we don't have to change it each year once a new Postgres version comes out. This is why we have, instead of a Debian control file, we actually have a Debian control.in file. And then there's a tool called PG BuildExt, originally written by Dimitri Fontaine 1 or 2 decades ago, and then maintained by me and the other Postgres maintainers since then. And that tool is, among other responsibilities, responsible for actually rewriting that control.in file to the actual control file. So it basically looks like this. I just pick one random extension that I happen to have on the system here. This Postgres Semver extension, originally the upstream author is actually David here. And in this control file, we say the name of the package, the name of the Debian maintainer, in this case, the group. There's a few uploaders, there's build dependencies and other things that are omitted here because the slide was already full. And then we have, next to this source section, we have a package section. And here we have this placeholder, PostgreSQL -pg version -semver. And once we feed this control in file through this PG BuildExt tool, it will generate the control file, which then expands this PG version placeholder to actually a list of packages. So this is just a mechanical translation. So we have Postgres 15, Semver, 16, 17, and whatever other version is supported at that point. Okay, and then once a new Postgres version is released, Postgres 18 comes out, we don't have to touch anything in this control.in file. We just rerun this PG BuildExt update control command, and it will automatically add the new package in that file there. There's about half a dozen layers talking to each other when building a package there. On the lowest level, no one actually touches it at that level, but Debian packages are actually AR archives, the one from library fame. with yet another archive inside called control tar.xset and something, but no one actually touches it at that level anymore. We have dpackage on top of that, which provides some building blocks for creating actual Debian packages. So you would call dpackage build dep and other dpackage helpers to actually create a package from that. But because this is complicated, there's yet another level on top of that called dep helper. This is the actual standard for building Debian packages nowadays. So instead of invoking all the dpackage tools directly, everyone uses these dep helper tools, which provide some wrappers for the most common build steps that are executed. I will show an example in a second. And next to these wrappers for calling create me a package, copy all files, and so on, there's also this program called it's just called DH. It's called a sequencer because it will invoke all the other tools in the correct order. So let me show you an example before it gets too confusing. So the top level command to actually build a Debian package, so to create the binary packages from the source package, is called dpackage build package, and it will invoke this Debian rules file. This Debian rules file is where all the commands go that are used to build a package. For historical reason, it's a make file. And in the shortest incantation, it just says for anything that is called, invoke this DH sequencer with some arguments. Let me skip ahead one more slide. And if we are actually running it like that, it kind of looks like this. I'm invoking dpackage build package. Dpackage build package invokes Debian rules with target name. Debian rules invokes DH, and DH then calls all the helper steps that are required for getting the package to run. So the first one would be DH update autotools config. So if any ancient autoconf things are used there, it will be updated. The package will be reconfigured, and then it will be built and so on. So this was the generic Debian part. Postgres actually adds more automation on top of that. This is this DH with PGXS step. So let me go back 2 slides. And we have this PGXS plugin for dep helper, which adds more build steps that actually call out this tool called pgbuildx, which actually interfaces with the PGXS build system in your extension package. So basically, dep helper calls this PGXS plugin, and this PGXS plugin calls pgbuildx, and this one finally invokes the make command, including any pgconfig or whatever settings that are required for compiling this extension. So if we go back to the output here, we can see that one of the steps here is actually invoking this pgbuildx tool, and pgbuildx will then continue to actually compiling this extension. Yeah, this means in the normal case, for extensions that don't do anything special, you will actually get away with a very short Debian rules file. Most of the time, it's just a few lines. In this case, I added more configuration for two of the helpers here. For in this step, I told DH install changelogs that in this package, the changelog has a file name that DH install changelog doesn't automatically recognize. So usually if you have a file called changelog, it will be automatically picked up. But in this case, I told it to use this file. And then I'm telling it that some documentation files should be included in all packages. Everything else is standard and will be picked up by the default Debian toolchain. Okay, another thing specific for the Postgres bits here is that we like to actually run the package tests at build time. So one of the build steps that gets executed is this DH-PGXS test wrapper, which in turn invokes pgbuildx install check, and that will create a new Postgres cluster, and then proceed to invoke pgregress on that package. This is actually the place where this patch that Peter was talking about 2 weeks ago is coming into play. So the actual call chain of events is that DHPGXS starts pgbuildx install check. pgbuildx starts pgvirtualenv, which is a small wrapper shipped with Debian, but not very specific to Debian, that just creates a new Postgres environment and then executes any command in that environment. This is actually very handy to create test instances. I'm using that all day. So if anyone is asking me, can you try this on Postgres 15 or something, I'm using pgvirtualenv-v15 to fire up a temporary Postgres instance. I can then play with it, break it or something, and as soon as I exit the shell that pgvirtualenv opens, the cluster will be deleted again. So in the context of pgbuildx, what pgvirtualenv is doing here is that it's calling pgcreateCluster to actually fire up that instance, and it's passing an option to set this extension control path to the temporary directory that the extension was installed to during the build process. So while we are compiling the package, the actual install command is invoked, but it does not write to user share Postgres something, but it writes to subdirectory of the package build directory. So it's writing to Debian /package name / the original path. And that's why before we had this in Postgres 18, the Debian packages have a patch that actually does the same thing as this extension control path setting. It was called extension desdir. It was basically doing the same thing, except that it was always assuming that you had this structure of some prefix and then the original path. The new patch is more flexible, that this can be an arbitrary directory. The old extension destir patch assumed that it's always something / user share Postgres something. Okay, so that I'm glad that that patch finally went in, and yeah, we can still run the test at build time. Okay, so far we've only seen how to build things for one Postgres version. The reason why this PG build-ext layer is there is that this tool is actually the one that does the building for each version in turn. So PG build-ext will execute any command passed to it for all the versions that are currently supported by that package. So what's happening here is that we have one source package per extension covered, and that one source package then builds a separate binary for each of the major versions covered, but it does this from a single build run. In contrast to what Defrim and is doing with the RPM packages, he's actually invoking the build several times separately for each version. We could also have done this. It's just a design choice that we've done it one way around and he's doing it the other way around. To tell PG build-ext which versions are actually supported by the package, there's a file called Debian/PG versions, which usually just contains a single line where you can either say all versions are supported, or you can say that anything starting 9.1 or starting Postgres 15 and later is supported. So this example here, 9.1 is 9.1 plus is actually copied from the Semver package because the requirement there was that it needs to support extensions, and that's when 9.1 was introduced. We don't care about these old versions anymore, but the file was never changed since then when it was written. Okay, so we know how to build several Postgres major versions from a source package. Now the next axis is supporting multiple architectures. There the build is just invoked separately for each architecture. So this single source package is compiled several times for each architecture. On APT PostgreSQL.org, we are currently supporting AMD 64, ARM 64, and PPC 64 in Little Endian. We used to have S390X support, but I killed that recently because IBM is not supporting any build machine anymore that actually works. Inside Debian, there's a lot more architectures supported, and there's also something called Debian ports, which are not official architectures, but either new architectures that are being introduced, like this long 64 thing, or sometimes it's old architectures that are not official anymore, but are still being kept around, like the Spark one. There's also some experimental things like HERT, AMD 64, HERT i368 isn't even Linux. This is a HERT kernel, but still running everything Debian on top of it. And some time ago, it even started to support Postgres. So the packages are even passing the tests there, which is kind of surprising for something that hasn't ever seen any production. Can show you an example of that? Just a second. So for Postgres 17, it looks like this. So the architectures in the upper half of that table are the official ones, and the gray area on the bottom are the, let's say, unofficial ones that are, let's say, less supported. So if anything breaks in the upper half, maintainers are supposed to fix it. If anything breaks in the lower half, people might care or might not care. I like to keep it working because if Postgres breaks, all the other software that needs libpq, so it's not even extensions, but any software that depends on libpq wouldn't work anymore if that's not being built anymore. So I try to keep everything updated there, but sometimes some architectures are very weird and just don't work. But at the moment, it looks quite good. We even got Postgres 18 running recently. Yeah, that there were some problems with that until last week, but I actually got that fixed on the PG Hackers list. Okay, so we have several Postgres major versions. We have several architectures, but we also have multiple distribution releases. So for Debian, this is currently SID or unstable. Trixie currently testing. Bookworm, Bullseye. There's Ubuntu, Pluggy, Oracular, Noble, Jammy, Focal. I get to know one funny adjective each year once Ubuntu releases something new. And we're compiling things for each of those. And because compiling things yields a different result on each of these distributions, we want things to have different version numbers. So people can actually tell apart where the package is coming from. And also, if you're upgrading, let's say, from Debian Bullseye to Debian Bookworm, you want new Postgres packages compiled for Bookworm. So things in Bookworm need to have higher version numbers than things in Bullseye. So you actually get an upgrade if you are upgrading the operating system. This means that packages have slightly different version numbers. And what I said before, that it's just one source package, it's kind of not true because once we have new version numbers, we also get new source packages, but these just differ in a new changelog entry. So it's basically the same thing. They just get a new changelog entry added, which is automatically created. That includes this plus version number part. I should probably show you an example somewhere. So do I have it anywhere? Okay, I can show it later. So what we're doing is that the original version number gets uploaded to Debian, but packages that show up on app PostgreSQL.org have a marker inside the version number that says pgdg plus the distribution release number. So for the Ubuntu version, it says pgdg 2404 or something, and in Debian it's plus 120 something. The original source package is tweaked a bit using this shell script here. I'm not going to show it now because it's quite long, but you can look it up there. This is mostly about creating these extra version numbers for these special distributions. It applies a few other tweaks to get packages working in older releases. Usually we can just take the original source or source package and recompile it on the older Debians and older Ubuntus. But sometimes build dependencies are not there or have different names, or some feature doesn't work. And in that case, this generate pgdg source has some tweaks which basically invokes set commands on the source package to change some minor bits. We try to keep that to minimum, but sometimes things don't work out. For example, when this XZ compression support was new in Postgres, the older Postgres, compiling the newer Postgres versions for the older releases required some tweaks to disable that on the older releases because they didn't have the required libraries yet. Yeah, and if you're putting it all together, you get this combinatorial explosion. So from one project, PostgreSQL Semver, we get this many builds. And each of those builds is actually, I can actually show you the actual page. And each of those builds is actually several packages. If you look at the list of artifacts there, it's creating one package for Postgres 10, 11, 12, and so on. So at the moment, it's still building for Postgres 10 because I never disabled that. I'm not going to complain if the support for the older versions is broken at some point. It's just being done at the moment because it doesn't cost much. Okay, and that means that, yeah, from one source package, quite a lot of artifacts are being produced. The current statistics are this. So we have 63,000 deb files. That's 2,400 distinct package names. So package dash Postgres version number mostly, built from that many source packages. The actual number of distinct source packages is 210. So that's, let's say half of that is extensions. Then there's, of course, separate source packages for Postgres 10, 11, 12, and so on. And there's a few application packages. Yeah, in total, the repository is 47 gigabytes at the moment. Yeah, we are. So this is actually current stuff. So all the old distributions are actually moved to apt archive PostgreSQL.org. And also we are only keeping the latest build inside the repository. So if you're looking for the second latest version of something, you can go to apt archive PostgreSQL.org. I don't have statistics for that, but that is much larger. It's, if I had to guess, I would say probably something like 400 gigabytes, something like that. I could also be off with guessing. Okay, so that was how to get from the source to the actual packages. What we are doing on top of that is doing more testing. So next to the tests that we are running at build time, we are also running tests at installation time, or at once the package is installed, we can run tests. For many packages, that's actually the same tests, just rerun on the actual binaries as installed, as opposed to Debian / something. Sometimes it's also different tests. from some tests, it's just a simple smoke test. Did everything get installed to the correct location, and does the service actually start? Sometimes it's also complicated, more complex things. Problems there are that many test suites are meant to be run at compilation time, but we want to run them at install time. This is kind of make check versus make install check. But sometimes some projects are not really prepared to do that, and they really want to, before you can run the test suite, you have to basically compile everything. I try to avoid that because things that work at compilation time might not mean that it's running at install time because we forgot to install some parts of the build. So I try to get the test suite actually running with as few compilation steps as possible, but sometimes it just doesn't work. Sometimes you can, sometimes the make file assumes that configure was ran and that certain variables got substituted somewhere. Sometimes you can get it running by calling make with more parameters, but it tends to break easily if something changes upstream. So if you are an extension author, please think of someone not compiling your software but still wanting to run the tests. And what we're doing there is to run these tests actually each month. So on each day, each month, a random set of tests is scheduled. That's 3 or 4 per day or something. I'm not running everything each day because if then something breaks, I can't fix 50 things in parallel. And so the whole thing, it doesn't want to move the, there it is. You can see the tests if you're going to this test suite tabs there. At the moment, actually everything worked. For example, we could check something was, so with this background worker REPL status thing, that's an extension that Magnus wrote some time ago. Everything is running fine, okay, but something was broken in January. There the S390 machine was acting up. That was probably a pretty boring failure, probably something with network broken. So not too interesting. This is actually why I shut down this architecture, because the build machine was always having weird problems. So yeah, this is how we keep the system actually healthy and running. One thing that's also catching problems is called deb check. This is a static installability analysis tool by Debian. So you feed it a set of packages and it will tell you if everything is installable. So in this case, something was not installable on Debian testing. And if we scroll down there, it would say that PostgreSQL 10-ICU-ext was not installable because this libICU72 package was missing. What happened there is that projects or library change zone name from time to time, and in this case, in Debian, ICU was moving from 7.2 to 7.6, and I just had to recompile this module to make it work. So usually if something breaks, it's usually on the development suites, Debian Zit, Debian Trixie, unstable and testing. The others usually don't break. If the others break, then I mess something up. Yeah, that's the Jenkins view there. Yeah, so that was, let's say, a short tour of how the packaging there works. For open issues or pain points that there might be, there are packages that don't have any tests. That's if we are looking at, what was the number, 63,000 packages. I'm not going to test them by hand. So we really rely on everything being tested automatically. So extensions are usually very well covered. So there's usually not a problem. Sometimes there's extensions that don't have tests, but they are kind of hard to test. For example, modules that don't produce any SQL output, like auto explain, are kind of hard to test because the output goes somewhere else. I mean, in the concrete case, auto explain probably has tests, but sometimes it's things that are not as easily testable as new data types. Things that usually don't have tests by nature is GUI applications. Any program that opens a window is hard to test. But anything that produces text output is usually something I like to cover. And problems with software that we are shipping and that actually breaks in production is usually in the area where the tests were not existing before. One problem is that some upstreams for extensions only start supporting Postgres 18 after the release. People should really start doing that before, so we can create the packages before the 18.0 release is there. Not sure when the actual best point to start would be. Maybe today, because yesterday was feature freeze. But sometime during the summer would be awesome. Otherwise, Devrim and I will go chasing people and telling them, please fix that. We will start building so we have, of course, packages for Postgres 18, but we don't have extension packages for Postgres 18 yet. I will start building that, yeah, perhaps now after feature freeze. Let's see how much works and not. Usually it's about, yeah, more than half of the packages just work. Some have trivial problems and some have hard problems, and I don't know yet if Postgres 18 will be a release with more hard problems or more trivial problems. Another problem that we're running into sometimes is that upstream only cares about 64-bit Intel and nothing else. We actually recently stopped caring about 32-bit for extensions completely. So Debian and app PostgreSQL is not building any extension packages for any 32-bit architecture anymore. So we killed i368, but we also killed ARM and so on the Debian side. And the reason is that there's too many weird bugs that I have to fix or at least find, and then chase upstreams about fixing their 32-bit problems. And they usually tell me, I don't have any 32-bit environment to test, and they don't really care. And in the end, there's no users of most extensions on 32-bit anyway. So we decided that it just doesn't make sense to fix that. And in order to prevent the problems from appearing in the first place, we just disabled everything 32-bit for the extensions. The server is still being built. It behaves nicely. Well, I did find a 32-bit problem in Postgres 18 last week, but that was easy to fix and not that much of a problem. But my life got a lot better once I started not caring about 32-bit anymore. Now the only problem left is big endian S390X in Debian, but that doesn't cause that many problems. One thing where we are only covering a bit of stuff is if projects have multiple active branches. There are some projects that do separate releases per Postgres major version. For example, PG Audit has separate branches for each of the Postgres versions. So we are tracking those separately just to make PG Audit available. PG Hint Plans is the same, and this PostgreSQL graph extension thing is also the same. This is just to support all the Postgres major versions. We have separate source packages for each of the major versions, which is kind of a pain, but doesn't work otherwise. Where we are not supporting several branches is if upstream is maintaining several branches in parallel. For example, PostGIS is maintaining 3.5, 3.4, 3.3, and so on. And we are always only packaging the latest one. Same for PG Pool, and there's probably other projects that do that. We just don't do that because it would be even more packages we have to take care of. So we're just packaging the latest one, and so far there were not that many complaints about it. Yeah, and possibly next on the roadmap is looking at what to do with Rust extensions. We don't have anything Rust yet, but that will probably be coming. So it's probably not very hard. The question is just how much of the build dependencies of the average extension is already covered in Debian packages, and how much would we have to build, or do we just go and render all the dependencies, or what's the best way forward there? There's actually a very small number of packages that are shipped on app PostgreSQL.org that are not in Debian for this reason. For example, the PL Java extension is not in Debian because too many of the build dependencies are not packaged in Debian, and I have not enough free time to actually care about those Java things, and I can't talk Java anyway, so it wouldn't make much sense anyway. Okay, I hope that was not too much in a too short time.
That was great. Thank you.
Thanks for listening, and I'm opening for any questions.
I think Pablo, you had a question about virtualenv.
Yeah, I have one. So when you show the PG virtual env usage. So do you use pre-built binaries or you rebuild every time, like for every new version you are using? Like
No, that's using the pre-built binaries.
okay.
So the way it works is you just have to, of course, you have to have it installed. I have many Postgres versions installed on that machine, and then I can just go and say PG virtual env, and I want an, let's say, 8.2 server. It's calling initdb. On the newer version, it's actually telling it to skip the fsync. That's why 8.3 was taking a bit longer, because it doesn't have that option yet. And there it's setting the PG port and PG host and so on variables, so I can just connect and then play with this old server. Okay, the problem is that PSQL broke compatibility at some point, but it's still working for sending normal commands.
It's too modern PSQL. Yeah, that's cool. Can you add like not only like vanilla Postgres, but any other flavors like I don't know, by EDB
Okay.
or Cybertech or
I've thought about supporting that. The problem there is that there's conflicting requirements. So what we've done on this Cybertech side is that if the other Postgres distribution wants to be compatible to this one, it really has to place things in the same directories. So it's installing to exactly this location. And if it's actually behaving like the original, it will just work. If it's installing to /opt edb something, it's not supported at the moment, but that's something that we could easily add there. What it's really doing is just invoking the existing tools with enough parameters to put the data directory into some temporary location.
yeah, and one more question. You had Go extensions mentioned on your last slide, but you didn't tell anything about those.
And the story is the same with as with Rust. We
Yeah.
have not done anything with it yet, and we need to explore it.
Yeah, Yuri was saying a bit about that in the chat. It seems like the problem is that both of them expect to download most of their dependencies, and vendoring them swells up the size of the download. And since they're not runtime dependencies, but compile time dependencies, it seems kind of silly to make packages.
Yeah. So for Debian, the answer is that Debian wants to be self-contained. So it needs to be, so downloading things from the internet at build time is prohibited. The ideal solution is to really package everything. If it's things that are really used only by one package, then vendoring the modules might be an option, but people will look funny at you if you try to do that.
I can jump in for a second. This is Yuri. I wrote a couple of comments on Rust here. I think part of the problem here is that in Rust ecosystem in particular, it's very common to have a lot of dependencies, as in hundreds. When you start, having one dependency and that dependency brings another dependency. And also the other part of the problem is that you might depend on a particular range of versions of particular dependencies and others depend on others. So packaging all of that as individual dependencies is becoming something that is really difficult to accomplish. And so vendorizing and putting that as part of the source is something that we could do to avoid the problem.
Yeah, of course, it's the easy solution. So some of the programming language ecosystems fit better into Debian than others. So I don't know how good Rust fits or not. So what I know from the Java world is that they also like to version everything and put version restrictions on their dependencies. But what the Debian Java packaging helpers are doing is just to nuke all those restrictions away and just use the latest version. And usually that just works. So you're reducing the problem by one axis by having everything at the latest version. No idea how reasonable the Rust version ranges there are. So if you can just ignore them and things still work, or
realistically, this is impossible. And they do require particular versions, and they will not compile oftentimes. And the whole toolchain expects particular versions. And this is not only dependencies themselves, but it's also Rust itself. So a package or extension can have a particular sort of demand for minimum supported Rust version. So if that version is not available in particular distro, you just can't compile.
Yeah, then the answer is we don't compile and you don't get it.
Right.
Yeah,
so
I mean,
yeah.
Rust is possibly still very new and people depend on the latest features and then are possibly just out of luck if they want something on Debian Bullseye. But at some point that problem should resolve itself and Rust get more stable, so that problem is not as common anymore.
It's an interesting take, actually, because if you think about it, the languages that have been around for much longer should have solved this problem. But if you look at, I don't know, C, C++, so GCC and Clang, right? They keep evolving and changing, all the time too. So there's also a problem. There's a lot of code, say in C++, that would not compile with a compiler that is older than, say, 3 years. So
Yeah, but
we see that even old languages have this same problem.
But Postgres knows about that problem and just doesn't use any features that are not available in all compilers. So Postgres has solved the problem.
Others not so much.
Yeah, but
others
then
can do whatever they want.
So if upstream doesn't care about their users, that's upstream's problem.
Yeah, I think there's
kind of to say.
They're like a centralized place where like the discussion of how to manage stuff like Go and Rust do on packaging systems is happening because I think it's reaching a point where there's so much stuff that we've got to figure out how to work up a solution.
Somewhat. 100%, yeah.
Yeah.
We need to find
so we can actually do backports of certain things in the repository and make certain toolchain bits available on the older distributions. But you have to stop at some point. So I'm certainly not going to introduce GCC backports because I just can't manage that. And so far we haven't done much of that. So I think Devrim is actually backporting parts of the GIS toolchain like GDAL and libproj or something. I've always been using what is available in the base distribution for that. So there is some room for making it work, but it's always the question of how much extra work we want to put in, how much we want to deviate from the base distribution, and ultimately also support the security bits of that.
Well, thinking of needing to stop at some point, it's come time, the point where we need to stop. I want to remind everybody that in 2 weeks, we're going to have a panel session on the user point of view. These are the users of extensions and, what they like and what the pain points are for them, which I think will be very useful for those of us who develop extensions. And then 2 weeks after that, Gabrielle is going to talk about extension management and cloud native Postgres. And until then, thanks everybody for coming.
Thank you.